So in today's revision lecture, we have to discuss some topics which were remaining from unit number 1. In last lecture, we discussed about classification of gear to terminologies, then law of gearing and concept of velocity of sliding, then the concept of length of arc of contact, path of contact, and contact ratio. These topics we discussed in last unit. Today we have to discuss these remaining topics, that is interference, undercutting, and condition for determining minimum number of teeth on gear and pinion, its derivations, the concept of rack shift, force analysis, and then numerical topics. This is from unit number 1. So we'll discuss now one by one. PPT is visible to you?
Yes, sir.
Okay, so we'll start with concept of interference. You can see here, basically when interference occurs, that we discuss. Whenever mating of two non-conjugate or two non-involved tooth profile occurs, then there will be interference. Means if the two profiles, gear two profiles, which will be in mesh, are of same, maybe involute or both are of involute form, then there will be no interference. But if involute meshes with cycloid or any other, you can say if there is meshing of two non-conjugate or non-involute profile, then there will be interference. So actually when it occurs, you can see here, whenever tip of the tooth undercut root on its mating gear. Let's say you can say this is pinion and this is gear. If this tip of the pinion, some tip of the wheel cut some portion of this pinion, then that phenomenon is called the interference. So tip of the tooth of one gear undercuts the root on its mating gear. This phenomenon is called the interference. And when it, what basically undercutting is, you can see the portion of when the portion of dedendum falls inside the base circle. This one is base circle. So if this portion, so portion above the pitch circle is addendum, and portion above the pitch circle is below the pitch circle is dedendum. So if this portion of the dedendum falls inside the base circle, then the profile of tooth inside the base circle is radial, or you can say addendum of mating gear is more than limiting value. So there will be interference with the dedendum of pinion and it removes the material. You can say a gear having its material removed in this manner is said to be undercut, and the process is called undercutting. You can simply say, see here, when there will be interference, whenever this profile, let's say involute profile, meshes with non-involute profile. When we call involute or non-involute, the portion below the base circle is non-involute profile, above the base circle is a involute profile. So this non-involute profile of the pinion meshes with involute profile of the gear, so there will be interference. Now what happened during interference, we can see the material which is below the base circle, means the non-involute portion, is get removed. So in interference, when this material is cut, that process is called undercut, and that whole process is called the undercutting. So due to interference, there will be undercutting. I hope you understand basics of interference and undercutting, why there is interference and what happened due to interference. Now we need to see some conditions to avoid the interference. So try to understand this diagram first. In this diagram, you can see different circles are shown for a pinion and gear. Basically, this is pinion which rotates about a center of rotation O1, while this gear or wheel rotates about center of rotation O2, having angular velocity omega1 and angular velocity omega2. Assuming these are external, having external meshing, this will rotate in a opposite direction. Now what which circles are considered here? You can see this one is the base circle, this one pink one, then this is pitch circle. So base circle, pitch circle, and the two addendum circles are shown. So in the previous session we discussed about path of approach. So this KPL is path of approach, and we know that we can extend this path of approach up to point M and N. Means up to the point wherever this common normal through this point of contact is tangent to base circle. So it is tangent to base circle up to point M and N. In this Kp, or I'm saying Kl, can be extended up to MP and Pn. So Kp can be extended to MP, while PL can be extended to PL. So maximum path of approach is MP, while maximum path of recess is Pn. So if I consider this green color addendum, then it is, you can see the addendum radius is O1L. But here one more is considered, that is nothing but a O1N. So what is these two addendum circles are, that we'll discuss later. Similarly for wheel, you can say this is, you can see this one is base circle, this one is pitch circle, and this one is addendum radius up to K, and one more is up to M. Means why these two circles are shown, we can extend this addendum radius. Let's say consider about pinion. O1L is addendum radius shown by, and this addendum circle is shown by green color. So this O1L I can extend up to N point. Why up to N point? Because up to that point, this common normal is tangent to base circle. And if I extend this radius beyond this point, means if I extend this pinion radius beyond O1N, this contact point falls inside the base circle. When it is inside the base circle, it will be non-involute. So basic is what? The point of contact should occur between two involute profiles. If point of contact occurs between two non-involute or two non-conjugate profiles, there will be interference. So to avoid that, we can extend this addendum radius, means it is shown here. We can extend this addendum radius, that is O1N, you can say, up to this point only. If I increase it, let's say like this, if I increase this radius beyond this point, then it falls inside the base circle. So this one is base circle. It falls, this point of contact is inside the base circle, anywhere here. And there will be interference. Means what we understand here, we can increase the addendum radius up to the point of tangency. Which are the point of tangency? M and N. So we can increase this point of tangency, we can increase this addendum radius up to these points, that is up to, here it is up to N point, and here it is up to M point. But if I increase this beyond that, there will be interference. So maximum addendum radius of pinion to avoid the interference is O1N. So we can say like this, it should be O1N from N to O1. While for wheel, it is from O2 to M. So this is maximum addendum radius to avoid the interference. Now based on this, we can find out what is minimum number of teeth to avoid the interference on pinion and wheel. So this is one derivation, important derivation, to find out minimum number of teeth and on pinion and wheel to avoid the interference. Can anyone tell me how the derivation is? How we can derive that expression? I told you what is maximum addendum radius, that is O1N, and O2M are the maximum addendum radius. How we can start that derivation? I'm not going to discuss whole derivation, but I just give you idea how to remember that. Yes? Hello, am I audible?
Yes, sir.
Okay. So how we can derive that expression? Okay. I hope you understand what is maximum addendum radius to avoid interference for pinion and wheel. For pinion it is O1N, and for wheel it is O2M. So I discussed with you what is interference and basic concepts. Why interference is there? You can see this is undercutting when this wheel cuts the non-involute portion of the pinion. So to avoid the interference, yes, no see. So to avoid the interference, we can increase this addendum radius up to of the pinion up to O1N. And so maximum addendum will be, as this will be addendum circle, you can see this one is addendum circle. I'm saying this is maximum addendum circle. So addendum is equal to addendum minus pitch circle. So this one is pitch circle now. So your addendum radius is O1n and pitch circle radius is O1p. So addendum is nothing but this distance. So how much it is? It is simply O1n minus O1p. So maximum addendum to avoid the interference is O1n minus O1p. That is discussed here. So first of all, find out O1n value, which is maximum addendum radius. And we prove here, or we find out here maximum addendum radius, that is O1n or RA max. Maximum addendum radius is this much. It is R, actually it is O1n square. So it will be equal to square root of mt by 2 into root of 1 plus t by t. This t by t is nothing but g. So simple formula is m into t by 2 in bracket 1 plus g upon, this one is g, that is t by t is g. So g into g plus 2 sine square pi. Remember, this is value of maximum addendum radius, or you can say limiting radius of pinion to avoid the interference. Now based on this addendum radius, we can determine addendum of the pinion to avoid the interference. So in first step, I determine maximum addendum radius. In second step, we are finding maximum addendum of the pinion to avoid the interference. And how much it is? It is addendum radius, that is O1n, minus pitch circle radius. So it is nothing but, it is addendum is equal to RA max. Here it is small r we are using because it is pinion. So this must be a small r. So it is RA minus R for pinion, and for wheel it will be capital. So I can determine addendum of the pinion to avoid the interference. It is nothing but O1n minus O1p, but O1p is nothing but mt by 2. So put here, and it is known to you, this addendum of the pinion is also equal to AP into M. What is AP into M? AP is addendum coefficient of the pinion and M is module. So if I can equate the standard addendum value to maximum addendum that you can provide to avoid the interference. So by equating to these two equations, we will get the value of minimum number of teeth on pinion to avoid the interference. So what I did, we find out first RA max. Then we determine, in second step, we determine addendum max. And third, this equate to standard value to obtain teeth. So equate this addendum maximum, how much I can provide to avoid the interference with the standard addendum value, that value is AP into M. So by equating these two equations, we get value of teeth or minimum number of teeth on pinion to avoid interference is this much. It is twice AP upon root of, you can see this. So it is twice AP upon root of 1 plus t by t is g, 1 plus g into g plus sine square phi minus 1. So likewise, we can also derive this expression, that is expression means expression for minimum number of teeth on pinion to avoid the interference. Similarly, we can derive it for a wheel also, that is capital T. And that capital T is, the procedure is same. Consider maximum addendum radius. Now you hear it for wheel, it is O2m. Then subtract this O2p from this O2m, we get maximum addendum. So this is O2m means maximum addendum radius. Then subtract pitch circle radius from this maximum addendum radius to obtain maximum addendum and equate it with the standard addendum value, that is AW into M. Finally, we will obtain expression for minimum number of teeth on wheel to avoid interference. It is value of, or expression for minimum number of teeth on wheel to avoid the interference. So till now we discuss expression for minimum number of teeth on pinion and wheel to avoid the interference. Further, you can put value of G, that is gear ratio is equal to 1. If I put in that expression, that is capital T, here if I put G is equal to 1, then we will obtain this expression. So this is simplified equation for a minimum number of teeth on wheel. Then for rack and pinion also we can determine when rack and pinion are in mesh, then what is minimum number of teeth on pinion to avoid interference with rack? So for finding this, we can consider this diagram. And again, the same way, we can find out maximum addendum to avoid the interference. And if you consider this diagram, the maximum addendum to avoid the interference for a rack, which is in mesh with pinion, is this much. So it will be from this to this. That is NH. So NH is maximum addendum radius. Procedure is again same. Determine maximum addendum, subtract pitch circle radius. That is from maximum addendum radius, subtract pitch circle radius, we get maximum addendum. Equate with standard addendum. By equating, we get expression for teeth on pinion. But here, as it is straight line, so NH is maximum addendum radius, NH is maximum addendum. So we'll equate this expression of NH with standard addendum value. So you can see here. Okay, so in the same way we can derive. First, I determine the NH value, that is maximum addendum value. Then you equate this NH with standard addendum, which is AR into M, but NH is in terms of PN. So just put value of this NH in terms of R and T, that is pitch circle radius and teeth. By equating this, we obtain our final expression, that is this T is equal to twice AR upon sin square phi. So this is your expression for minimum number of teeth on pinion to avoid interference when it is in mesh with a rack. So similar, like a pinion and wheel, we also see an expression for rack and pinion. Our next topic is methods to avoid the interference. In that, there are three methods basically we seen. In the first method is modified tooth profile, in which we can see, let's say this one is involute profile, and this one is a cycloidal profile. So what we do to avoid the interference, the portion, let's say this is gear number 1 and this is gear 2, which are in mesh. So the mating profile will be same. We design the profile in such a way that the mating profile of the both gears will be same. So this addendum portion, we can say actually the addendum is above the pitch circle, but you can say this top portion of this gear tooth is made of involute form, while this bottom portion is made of cycloidal form. So this portion is in mesh with this. You can say this portion of this wheel is in mesh with this portion, bottom portion. As these mating portions, both are of involute, and we know now this bottom portion is meshed with top portion of this another wheel. So this portion, the cycloidal mesh with cycloidal and involute mesh with involute. So one way to avoid the interference is the mating profiles, gear tooth profiles will be same. So we modified it to profile in such a way that involute mesh with involute and cycloid mesh with cycloid. This is one of the method to avoid the interference. That is modified tooth profile method. Second method that already we discussed is, you can see here, we know that we can extend our addendum radius up to point of tangency, means up to this point, up to M I can extend and up to N I can extend. But we can't provide addendum radius more than this. But you see in this case, the addendum of the wheel is this much. That is O2K, where K is point of contact. But as this addendum radius of the wheel is more than maximum addendum radius, we can extend up to M only, but it is more than K, more than O2M. So there will be interference. And to avoid this, what we can do is, we can reduce this addendum radius. And up to where we can reduce, you can see, it must be less than O2M or equal to O2M. We can increase up to O2M only. So to avoid the interference, I have to reduce the addendum of the wheel. But if I reduce the addendum, you can see here. So for wheel, I have to reduce the addendum. But if I reduce the addendum, in order to maintain total depth, this one, in order to maintain total depth, this addendum must be increased. So addendum is decrease and addendum is increase to maintain total depth. It is for wheel. So for wheel, addendum is increase and addendum is decrease. But as this wheel portion is in mesh with pinion portion, the reverse we have to do. So for pinion, because addendum of the wheel is in mesh with, let's say I'm considering addendum of the wheel, pinion and addendum of the pinion. So this addendum of the pinion is in mesh with addendum of the wheel, and hence if addendum is decreased, this addendum must be decreased. And as this addendum of the pinion is in mesh with addendum of the wheel, as it is increased, this addendum must be increased. So what we done to avoid the interference, you can see here, for wheel, addendum is decrease and addendum is increase. While pinion, reverse way. Now we can see this in the next slide. You can observe here the current addendum radius is O2K, but by modified method, it is decreased. You can see now here this O2K is inside the M point. So you can see for wheel, addendum is decrease, while addendum is increase. And the reverse here, for pinion, addendum is increase, while addendum is decrease. And that already we discussed in last slide. So by this way, by modified addendum and addendum of the wheel and pinion, we can avoid the interference. And this is done by means of a rack shift. So third method to avoid the interference is we can change the center distance. So initially you can see here, initial center distance was O1, O2. As already this part we discussed, where I'm just discussing all these methods in brief. So this O1, O2 was initial center distance, but to avoid the interference, we shift this center distance from O1, O2 to O2, O1 dash. So center distance is shifted, and if center distance is shifted, we can see the pressure angle is increased. So initially it was pi, and later on it will be a pi dash. So by increasing center distance, pressure angle is increased, but the base circle radius as well as speed ratio, velocity ratio remains same. So we can avoid the interference by modifying center distance also. This is third method. So we see in three methods. One is modified tooth profile. Second one is modified addendum and addendum of the pinion and wheel. And third one is by modified center distance. These are the methods to avoid the interference. So second topic we discuss is methods to avoid the interference. First we discuss is expression for minimum number of teeth on pinion and wheel. And before that also we discuss what is interference and rack shift. Interference and undercutting. Now the concept of rack shift. As we seen in the previous section, that is in methods to avoid the interference, we seen for a wheel, addendum is decrease, while addendum is increase. And for pinion, let's say it is for wheel. For pinion, the reverse thing means addendum is increase and addendum is decrease. I told you at that time, this is achieved by shifting the rack. So what happened, as you can see for wheel, addendum is decrease, but piece circle radius will remain same. I will show you in that slide only. So remember this. Now you can see the initial diagram. Here, this was original addendum radius, but in order to modify it, you have to decrease this. So when we decrease this addendum radius, you can see this one is wheel gear tooth. So when we decrease this addendum radius, the piece circle, which is here, so radius does not changes. But if radius does not change, radius is not changed, means what happened? Due to this, we can observe now this one is addendum, which is decrease, and this one is piece circle radius of the wheel. So what happened for a wheel, as addendum is decreased, width of the gear tooth at the piece circle get reduced. So this width get reduced. It was modified width, and this one is a initial width. While reverse happen in case of a pinion. For a pinion, the addendum is increase. So this one is initial width, or I'm saying thickness. And after modification, as it is increase, you can see the width also increases. So to achieve this, that means to reduce the width on a wheel and to increase the width on a pinion, we use a rack shift. So here you can see now, this one is rack cutter. So this rack cutter is used to cut the width of space or teeth on a gear. So this one is width which is going to cut on a gear is equal to the space between the two consecutive gears. So here, let's say this one is your original tooth thickness, while TP is thickness which is cut on a pinion. So to provide as on pinion, we need to increase the thickness, and hence to provide increased thickness on pinion, we have to shift this rack to the upper side by this amount, by E. So to provide increased tooth thickness on pinion, this rack is shifted from T, which is here at the center. It is shifted from, so initial on piece circle it is T, but to provide increased thickness, this rack is shifted towards upper side. So that is TP. So for pinion, this much is thickness. Rack is shifted up, but for wheel, it is shifted down to provide this thickness. That is TW. Further, you can determine what is value of TP and TW. That is nothing but T plus this distance. That is T plus twice C tan phi. So rack is shifted to provide increased width or tooth thickness on pinion and wheel. In the force analysis topic, on a spur gear, there are two types of forces are acting. One is, you can see this one is tangential force, FT, and one more is, that is radial force. So tangential force and radial force. Radial force acting along the radius, along this path it is acting. So if I, yes, we can see here now. So this one is a resultant force, okay, and it is combination of two. So it is shown here. It is this F, that is resultant force F. There are two components. One is FR and other one is FT. So let's say this one is FT, tangential force. This one is FR, that is radial force, and its resultant is resultant force. So this one is F. So simple, there are two forces we considered in spur gear: resultant force FR and FT. As this FR is acting radially, is acting along the radial direction, it will try to separate out the force, separate out the two gears. But tangential force is responsible for power transmission. So tangential force is responsible for torque, because torque is equal to Ft into R, and hence it will produce a power. Just we can remember this, and they are related by this angle. You can see this angle is phi. So relation between FR and FT we can determine. So Ft is equal to F cos phi and FR is equal to F sin phi. This is all about force analysis of a spur gear. So we discuss all these topics. We know the important formulas for spur gear. Starting from module, circular pitch, then gear ratio. So we discuss theory topics. Whatever now for numericals. We'll just go through important formulas. So we define module, diametral pitch, circular pitch, then angular velocity ratio, gear ratio, path of approach, path of contact, contact ratio, the velocity of sliding formula, rolling velocity, that is VR, and its ratio of sliding to rolling velocity when at the start of engagement, at the end of engagement, and at the pitch point. Then basic formula for pitch circle radius is equal to R into MT by 2, that is R is equal to module into T by 2. Then addendum radius, relation between addendum radius and pitch circle radius. Addendum radius is equal to pitch circle radius plus addendum. Formula for length of path of contact, that is KL is equal to KP plus PL. We discussed this formulas. Contact ratio formula. Angle turn through by pinion. Numericals can be asked on these formulas. So I already explained in the regular lectures how to determine this angle turn through by pinion. So that formula is also important. And then in numericals, I'm not going to discuss numericals, but I just remember you what we discussed in numericals. We've seen straightforward numericals to determine the different parameters like arc of contact, path of contact, provided that teeth, module, pressure angle is given. Simply, it is just straightforward. First, in the first step, determine pitch circle radius. Then determine addendum radius. Next, we can use this formula of length of path of contact in terms of Kp and Pl. So we can find out Kp and Pl, and then we can determine Kl. So, and then once path of contact is known, then we can determine arc of contact by using this formula. So first determine length of path of contact, length of arc of contact, and then contact ratio if asked. Okay. Likewise, straightforward numericals. It is also same numerical, second numerical, but in addition to that, that is finding pitch circle radius, addendum radius, path of contact, arc of contact. In addition to that, they also find out here contact ratio and angle turn through by pinion. So straightforward numericals based on concept of path of contact, arc of contact, and contact ratio. And then some numericals based on the concept of conditions that also we discussed. You may solve this. Means these conditions we need to use to solve the numericals. What is given here? Path of approach and path of recess is half of the maximum permissible length. So by using this condition, you can start your numericals. So this condition we have to use to determine different parameters. This condition is given. So the first part is straightforward numericals. Then we discuss some basic numericals based on concept of central distance. In this examination, as well as in NSM or NSM examination, numericals on central distance can be asked. So if central distance is known to you, then if central distance is known, we can determine teeth on each gear. So this kind of numericals ask for each gear, maybe a spur, helical, bevel, and worm. That means finding relations between central distance, teeth, module. Then last topic we discussed, there is second topic we discussed, numericals on concept of interference. So how to find interference? The formula of minimum number of teeth we have to use. Remember here one more thing I want to highlight here. Always use capital T formula first. Whenever we are finding minimum number of teeth on wheel and pinion, why to use this formula first? Already I explained in the regular lectures. If you remember, then it's good. If not, you need to think about that. So first we have to find out capital T, and then we can determine small t by using gear ratio. These are the numericals based on interference conditions. So determine capital T, small t, like here, capital T, small t, and then further we can determine again the same way. Once capital T and small t is known, we can determine radius, and hence further we can determine path of contact, path of approach, and recess. Only change is what? We need to determine minimum number of teeth to avoid the interference by using these formulas, that is capital T and small t formulas. But the condition is we should use first capital T, not small t. If you use small t, then it will give you wrong results. Why? You need to think about that. So third portion was numericals on interference concept, and some numericals will be asked whether they will ask whether interference will occur or not. So we need to check whether there is interference or not by using some conditions. So determine radius, then addendum, use the conditions which is given, and you can see here we determine addendum of the radius is 6.4 mm. Finally, we need to conclude something whether interference occurs or not based on equating the actual condition, that is actual value, and theoretical value. By comparing that, we can decide whether interference will occur or not. So numericals can be asked on the concept of whether there is interference or not, and we can check it by using different conditions that we studied. So this is numerical part of unit number 1, where we discuss different types of numericals based on the concept of center distance, then based on the concept of path of approach, path of recess, or basic terms, and at the last we discuss numericals on concept of interference. This is about unit number 1.